thank you very much for coming. We're going to be taking a little look at Chromium. You'll perhaps know what Chromium is. You'll find out in a moment if you don't. And its use in some embedded desktop applications. Okay. Now, in the Carolean period, it was very fashionable to build a big, expansive house like this and to have around the back a tradesman's entrance. In other words, an entrance that was part of the design. It was deliberate, it was supposed to be there, but there was a social implicit security contract that would be unguarded. The right people would use it, and the wrong people wouldn't. Okay, with that in mind, let's play a quick game. We're going to play a quick game to start. This is called Is It Chromium? It's a great game. You can play it in the car with the kids, and I'm going to show you an image, and you're going to tell me whether that application is Chromium. Okay, you'll get the hang of this. So you're going to shout yes or no. It's a quick fire round. Google Chrome. Is it Chromium? There's a clue in the name.
Yes.
It is. That's very good. Microsoft Edge. Is that Chromium?
Yes.
It certainly is. Opera browser. Is that Chromium?
Yes.
It is, since 2013. All of these browsers, Arc, Brave, Vivaldi, are they Chromium?
Yes.
They certainly are. Well done, you're getting the hang of this Discord desktop. Is it Chromium?
Yeah.
It is Chromium. Steam on the desktop, is it Chromium?
Yes.
It certainly is. Adobe Acrobat, Spotify, Notion desktop, are they Chromium?
Yes.
They certainly are. Photoshop, is it Chromium?
Yes.
No, I'm just trying to trick you now. Okay, VS Code and Git Kraken, two developer tools, are they Chromium? Are they Chromium?
No.
They are Chromium. IntelliJ, another developer tool, is it Chromium? Come on.
No.
It's not, it's very good. It may as well be, but it happens not to be. Slack, New Outlook, olk.exe, Teams, Zoom, are they Chromium?
Yes.
They certainly are. Blender, is it Chromium?
No.
No. The Windows 11 widgets stupid sidebar thingy with the apps. Is that Chromium?
Yes.
Of course it's Chromium. Loads, millions and millions of kiosks all around the world. Are they running Chromium?
Yes.
Yeah.
They certainly are. And finally, I kid you not, parts of the NASA mission control systems, are they Chromium?
Yes.
Yep.
They are, they are. So as a rule of thumb, is it Chromium? Probably yes, might be the answer. Okay, there we go. We've got this thing called Chromium. It's used all over the place, apparently, we've just discovered. What actually is it? Well, effectively, on a system, you're going to have a set of binaries like this. It looks very similar no matter what operating system you're on. Some of the important ones are highlighted, but effectively there is this whopping great DLL and this exe, or without the exe file extensions on a Unix-based system. And you can run that up and you'll get a window like that, and you'll probably see a window like that every single day. But what we want to know is how to take a window like that and embed it into a desktop application. Maybe just a part of our application, a little bit of the Chromium rendering engine that we're going to use for a part of our application. And there are three ways to do that. If you're unlucky enough to be a Java developer, you might use that one. C++ and .NET, you might use that one there. But this is by far the most popular. It's something called Electron, and that is for the Node.js platform. A really, really easy, just type out some JavaScript like you would for a website, but running with an interpreter called Node. Okay, so let's have a little look. What is this Node stuff? What is this Electron stuff even? Just slightly catch my breath. I have a basic HTML file here. Look, it's a basic HTML file. And it says, what a lovely HTML file. And then I have this main.js script. Okay, and this is a little bit of Electron bootstrapper script. It's a sort of minimum, working example. And what I can do is run a special command that looks like this up here. I can get out the other end an Electron application. Oh, I see, my screen resolution's changed because of this nice projector. Okay, I can get out a lovely little application like this. And look, it's our HTML file. It renders, it kind of works. And that file there is 209 megabytes. It's 209 megabytes. In fact, the entire copy of that application is now 330 megs. I mean, that's ridiculously inefficient. So what we've effectively shown is that Electron is a way to take a HTML file that might be a matter of kilobytes, it's actually 810 bytes, and turn it into something, in this case, literally 2 million times the size. Plus it eats up 216 megs of memory. It doesn't update itself. It introduces a host of security vulnerabilities, as I'm perhaps about to demonstrate. And what's more, we don't just have one of these on our system. We went through all those examples of Chromium at the beginning. We have so many copies of these, and they're all sitting next to each other. And it's too much to cope with. You know, you can't have that many copies of Chromium on a system, all just sitting there. Many of them running in the background because they think that RAM is just abundantly available. So Microsoft tried to tackle this problem a few years ago and said, we can't be having this. What we're going to do, we're going to ship one copy of Chromium with the operating system, and you can then embed that into your applications. And we will deal with updating that copy of Chromium, and we will make sure that it is vaguely secure, emphasis on the vaguely, and you can then use that as you wish and not have to worry about distributing your own copies of this web browser. Okay, there we go. So we've got some different forms of Chromium. It's quite an amorphous product. We've got the traditional Chrome, we've got loads of different browsers, we've got an Electron version of Chrome, we've got this thing called msedgewebview2, but whichever version of Chrome you've got, you are going to specify, when on instantiation of the process image, some important command line arguments. You might set the window size, you might do incognito mode, you might set a proxy server, etc. But there's one highlighted in blue, look, and that is not a coincidence, because there's an argument called remote debugging port. And that is exactly as ominous as it sounds. Let's see what it does. When we instantiate a Chromium image, we're going to get a big mummy Chromium process, and the big mummy Chromium process is going to have lots of babies very, very quickly, in a matter of seconds, maybe up to about 30 babies if you've got lots of tabs open. And she's going to give each baby a type equals argument and a user data dir. These are some more command line arguments. But we can see here, the big mummy Chromium process has been given a remote debugging port. Okay, that's very important. We say remote debugging port equals, and then some port number, is the TCP port, and if we do that, we can curl an endpoint on that port called JSON. I'm piping it into JQ here just to get some syntax highlighting, and we get, in the JSON response, this thing called a WebSocket debugger URL. Okay, very nice. A WebSocket debugger URL, what is that? If we then take a simple WebSocket client, so a little bit like Telnet or SSH, this is just a text-based back and forth, and we say, node package execute WizCAD, that's just the name of my WebSocket client, -c connect to that endpoint. We took a Chromium image, we told it open a debugging port, we got a page address on that debugging port, we connected to that debugging port. Okay, you with me so far? If we do this, we can specify, if we like, a series of commands to do anything on the browser. We actually have more power over the browser through this interface than we would with a keyboard and mouse being able to click various things on the website. We can do anything we want. Helpfully, the methods, this is a syntax called JSON RPC, remote procedure call. The methods are very helpfully named. It's not the sort of thing you get if mathematicians designed it, and you just get single letter variable names like I and J. Page.capture screenshot, browser.close, runtime.evaluate. This is very important. This allows us to run arbitrary JavaScript within any page in the browser. Okay, bit of wiring up then. We've got these Chromium things, we've got these remote debugging things, we've got these CDP commands. CDP, by the way, the Chrome DevTools protocol. In other words, that WebSockets-based interface to control the browser headlessly, remotely. There is an environment variable for our old friend msedgewebview2 called webview2 additional browser arguments, and this is meant for setting, something like a proxy server, something innocent and innocuous like that. But we can slightly abuse this mechanism. We can inject into these command line arguments remote debugging port. Okay, this might be good. This might be good. So, strategic integration of WebView2 into holistic. So the systematic. I'm joking. We're not doing it. We're going to do a live demo, and the live demo is going to involve the following thing. What's it going to involve there? It's going to involve, firstly, a copy of Microsoft Word. Here is Microsoft Word. I have a document open. I have this thing which is a random Microsoft Word add-in. There are thousands of these available. All of these add-ins these days just use a WebView2 embedded browser pane. Let's prove this. If I go to procx and we have a look, that's a bit blurry, isn't it? We can see that winword.exe has had a baby called msedgewebview2.exe. That's had some babies, which are all of its Chromium processes. Like the renderers, the utilities, the network utilities, etc. But if we look at that top msedgewebview2 process, it has some command line args, Let's open them up. We're going to look at this command line. Let's go to the end, and we can see, oh my goodness, look, amongst all of the other innocuous command line arguments, it's just setting the language. We have managed to inject our special command line argument. What is this going to allow us to do? What is this going to allow us to do? I think you might be able to work out the answer. Right. Let us curl, therefore. Dear me. Let us curl the endpoint. So we said 9555. Okay. Curl. In other words, HTTP get localhost my machine at 9555 JSON. Oh dear. That would have, yeah. Let's have some syntax highlighting. Okay. Let's take our WebSocket debugger O. Let's node package execute wizcat-c that address. And because it's a live demo and it's being watched, it's going to be excruciatingly slow. There we go, okay. Very good. We seem to have a connection. And let's see what we could do. So you're innocently using the word, and as I say, runtime.evaluate, arbitrary JavaScript injection. What could that enable us to do? We could craft some JavaScript to manipulate the DOM, do something like, oh dear, do something like this. We could pop up, well, my icon's not working because I don't, oh, there we go. We could pop up, we have literally done a phishing attack on Microsoft Word. Okay, we've done a phishing attack on Microsoft Word. We could do some very nasty things. We could try to steal money, etc. Maybe we could actually do something a little bit slightly more entertaining. Could we come along and say, there, that's nice. I mean, that's definitely more useful than cite while you write. I don't know, I just want to stare at that whilst I'm doing my coursework. I think that's great. However, that's just manipulating the DOM. We can open up any browser and do this. What is special about these WebView2 embedded Chromium implementations? The answer is they have something called native bridge methods. In other words, a mechanism for the embedded browser, to talk back to the host application. In this case, it's a C++ COM application. It's winword.exe, it's Microsoft Word. Okay. Let's see what sort of native bridge methods we might be dealing with. Okay, look, as they say on Blue Peter, here's one I prepared earlier. And this is a simple example, which is going to do return body.text. Okay, probably get an idea of what that does. Well, look, in my document, I had this bit of text here, and then I managed to say return body.text, and then I managed to get my amazing bit of text there. Look, it's the same bit of text. We just exfiltrated some text. Okay, if we can read text, what else can we do? Maybe we can take some text. No, thank you. Maybe we can take some text and inject it into the document. Let's have a little look. If I do that, then we don't get that because ich muss, warte mal, reconnect. There we go. Okay, let's have a look. Have I got the right thing on my clipboard? Perhaps not. Return by value true, injection successful, maybe. Oh look, that wasn't there before. Okay, we can read and write to the document. That's a bit interesting. Can we do anything slightly more surreptitious, slightly more pernicious than that? Okay, I have an expression here. Here's another one I prepared earlier. This expression says, let's have a look, what does it say? It says, office.auth.getAuth context. Now this is my university account. I don't particularly think the university will mind exposing their tenant ID, but you get the idea. You can do some reasonably pernicious things because of these native bridge methods, in many cases completely surreptitiously, clandestine, underhood, undetectably. And if you do this, then of course, because the desktop application, the native one, is a standard not memory safe application, there might be buffer overflow exploits, etc. This opens up a whole world of potential RCE vulnerabilities. Okay, does that mean we've got 6 minutes left? Is that right? I think so, possibly? Yeah, let's go for one last bit in the live demo, which is, you remember that electron thing from earlier? Here's our electron thing. Let's go to that directory there, win unpacked. Oh, look, there it is. Let's say electron test. Remote debugging port, let's give it 333 this time. You can put any number you want up to 65536. And we have our application. Okay, but if we have a look, let's have a look. Has it had some babies? It's had some babies. It's had a remote debugging port in the CLAs. Oh, there we go. And And it's had some babies. Right, let's do the same thing on this Electron application. Let's see if it works in approximately the same way. Let's take another command prompt. You can never have too many command prompts. And let's say curl. Let's take our WebSocket debugger Earl. You're getting the hang of this by this point, potentially. And let's say no package executes wizcat-c to that Earl. There we go, we're connected. And let's see if we've got some more. Here's one I prepared earlier. We've got some more here, one I prepared earlier. That's, well, it's not supposed to be a tongue twister. And let's put one of those in there. And oh my goodness, we have a message book. We could do, I mean, what's the classic RCE example? Is to instantiate calc, isn't it? Let's see if that works. Calc. Right, there we go. We have just run an arbitrary command on the system, instantiated as a sub-process of a completely trusted signed binary, something like Slack, Teams, Steam, whatever you want, deployed by your enterprise for your laptop usage, won't be picked up by the EDR system because, of course, you trust Slack, don't you? And we have managed to use it for RCE on the system. Let's do one more. Let's do one more. If we do an exec sync.toString, then we will in fact get back the string result of a command. Here, I'm going to execute a who am I. I'm going to execute a who am I, and oh my goodness, we get the result of the who am I, which I can prove to you is the same result. So, okay, what does this mean? What does this mean? We only had 20 minutes, but look, there is a world of vulnerabilities exposed by this thing called Chromium and embedding it into applications, including all sorts of ways to abuse the SSO mechanism. There's a mechanism in Windows to pass through the Entra ID PRT, the primary refresh token, in other words, the way of authenticating with Microsoft Azure Entra ID, through to the msedgewebview2 instance so that it can use it on your behalf to, conveniently reach out to Office and do telemetry and all sorts of things. Really, really dangerous. There are other parts of native bridge functions which are also interesting. There is a way of doing this from a remote machine, not just a remote application, but I could have a different computer and still hook into a remote Electron-based application. And if we had more time, then this would be very fun. But we don't. So what we're going to say is, so what? Well, look, you're only humans. You're not going to remember all of this. But if you're just taking away one thing from this talk, then it's this thing. CDP, the Chrome DevTools protocol, is shipped in production to be a fully featured, unauthenticated way of controlling the browser. Headlessly, remotely, silently, surreptitiously, dangerously. Okay. The vulnerability here is not Chromium, it's not the OS per se, it is the bridge between the two. We have spent 20 years trying to get the web out of the desktop. We have finally gotten there by making the desktop into a browser. We have gone back to square one. We have a new set of problems. And I hope that perhaps you've gleaned what some of those are from our little talk today. Okay, so the tradesman's entrance at the back of the house. What's the lesson? Just because there is a tradesman's entrance and it's convenient doesn't mean that it should be left open. Okay, and with that, I think we're gonna call it an end of the talk. But we've got like 2 minutes, so questions or thing, if there are any of those. Oh my goodness, hello.
Hi. I love your energy, Ben.
That's nice.
Honestly, I could listen to you read the phone book. So, I understood the middle bit. The first bit, the end bit. I've got the gist. I didn't understand the middle bit, but it didn't matter because I loved you.
The fishing in my use of words. There you are. That's all I need to know.
Yeah,
it's dangerous.
Exactly. Yeah. And I've not really got a question other to say if you honestly you were great, and if you were doing theatre. I don't mean it. No, seriously, I love theatre.
I'm at the Edinburgh Fringe later this year.
I can see you in that because I almost think you're wasted doing this, and you should put it all. Well done.
Thank you very much.
Yeah, I second the energy bit. Just wanted to ask, like, in terms of your findings, obviously reporting vulnerabilities, etc. Do you take this to someone, and you kind of put the kibosh on my question a little bit at the end because you said it's the bridge. I thought you might go to someone like Project Zero or something like that to talk about this, but are they the wrong people? In terms of responsible disclosure, or is this just a known thing that they all know?
There's an extent to which it's an unspoken secret. I'm not the first person in the universe to have discovered that you can inject this particular command line argument into this environment and be able to get this result. The problem with it is that it is, for the most part, undefensible. This is a debugging feature that's supposed to be there for developers. It's supposed to allow them in. And there is one group policy setting you can set to block opening the DevTools window in some instances, not for Electron, but in some certain subset of criteria for msedgewebview2.
Because given the situation and the world as it is, etc., there are massive glaring open vulnerabilities like this, and everyone's using these tools.
Yes, millions.
It's a little bit of a worry, right?
I mean, look, personally, rule of thumb, if it's an Electron application or an msedgewebview2 update, there will also be a browser version. You can get Teams and Slack on them, etc. on them. Just use it in the browser. You don't need to integrate it with your desktop, is my personal view. Okay, like one big caveat is you need to already be on the machine. This is not a mechanism of getting onto the machine, but once you're onto the machine, and it's not a mechanism of doing process elevation necessarily. I mean, you can obviously run your system commands and do your RCE to help you with that, but it is a very, very dangerous, pernicious and silent way of potentially causing a lot of damage. So yeah, maybe we should start reporting it to Project Zero, etc. But yeah, it's so widely pervaded, it's not really containable, at any rate.
It's one of those intended features, like a number of products. No, that's as we designed it. We're not going to do anything with it.
Yeah.
And in some ways, screwed if people know about it.
Yes, which they don't, until now. Okay, how are we doing?
Question if that's time.
That's time. It's gone, 30 seconds, one more question. No? Oh, no.
Why do you think Microsoft doesn't just ship an MSFU runtime that doesn't have this enabled for 99% of desktops?
I have no idea, because it would be a really good idea. There are some niche use cases where this is really useful for some developers some of the time, but when you're debugging, when you're creating an application,
my mother doesn't need it, my grandmother doesn't.
They certainly don't. So I made an example implementation of the WebView2 COM interface to work out how this works. And so you can do all the debugging you need from there. You don't need this command line argument. It shouldn't really be there. I don't know. Maybe we should go and find someone from Microsoft and work that one out. But there you go. Okay, thanks very much. And I think.